All right. And we are live, ladies and gentlemen. It's a pleasure to have you on board. Welcome to this live stream of Engineering Trainer TV, stream number 11. My name is Luc Hennen. I'm the CEO at engineeringtrainer.com. And today I'm honored to have a conversation with Geronimo Zamora Garcia, who is a pipe stress and pipe support specialist, and actually has quite a lot of experience with working with large EPC projects. Geronimo and Engineering Trainer have been working together for the past few months on several projects, which I'll show later on. So it's a pleasure to have him on board. And today we'll be discussing optimizing your Caesar 2 model building through PCFs. And then obviously in relation to SmartPlan 3D and the Caesar 2 software. And this topic is related to a 4-hour course that Geronimo will be providing on this specific topic during the month of October. So if you haven't seen that one, make sure to check it out if this topic is relevant for you. The link can be found in the show notes, as always. For this stream, we'll aim to roughly take, let's say, 30 to 40 minutes, depending a little bit on questions that are coming from the audience. Having said that, Geronimo, it's a pleasure to have you on board. How is your day
All
going so
right,
far?
all right, all right. Thank you so much for having me here, man. It's a pleasure and an honor.
Awesome.
And okay, all right. So a little introduction about myself. I'm a
Well,
mechanical.
sorry to
Oh, sorry.
interrupt, Geronimo. Give me one more second. I
Don't
always tend
worry.
to first invite everybody who's watching this stream to join the chat just before
Yes,
we dive into the real topic. Um,
you do.
So if you're watching, make sure to join the chat and let us know from where in the world you are joining in. It's always great to have a little bit
Yeah.
of interaction with people watching. All right, so we have Kevin watching from the Netherlands. Awesome, thanks for letting us know, Kevin. And as always, feel free to connect with me or with Geronimo on LinkedIn if you have any questions or you just want to connect and explore any opportunities. Um, Having said that, let's kick things off,
All
Geronimo.
right, all right, all
Maybe you
right.
could tell us a little bit about yourself.
Oh yeah, no. Just to sum up a little, I just all right. Again, I'm a mechanical engineer. Right, a little bit of educational background. Mechanical engineer, have a master's degree in engineering of applied mechanical engineering of process plants. Right.
Right.
Yes, and well, I've 13 plus years of professional experience, I would say. And well, I would say areas of expertise will be, pipe stress. It's a static, dynamic, analysis and piping support, materials, plan design, all those stuffs. Currently, I work in TR, all right, as the
Right.
biggest EPC company like in Europe, I would say, or one of the biggest.
Hmm.
And well, right now have different, let's say, jobs there, but I would say I am a piping stress and support leader for projects within TR, right? I'm currently in two, and we
Yeah.
have many projects. One is basically finishing, and the other one is halfway through. I'm also a piping stress global manager deputy. I work with Juan Carlos. You know you know him,
Definitely.
and
Yeah.
as his right hand. And also, well, I provide like piping stress technical advisory for the department, perform challenging stress calculations, carry out reviewing and auditing tasks, collaborate updating in-house procedures, collaborate with training activities, and all and so on. That's basically sums up.
Nice. Nice. And where are you based at this very moment, Geronimo?
So our headquarters are in Madrid. Basically, we have offices around the world, across the
Yeah.
world. Well, I'm
You
located in
you are
Madrid.
currently in Madrid, I guess.
Yeah, headquarters. Yeah, headquarters.
Yeah, so we have people tuning in from all over the world as always, which is a great pleasure. And one is an interesting comment which is worth exploring is Brazilian accent talking in English. Like you are not originally from Spain, right?
Brazilian accent. No, I'm not. I'm not from Spain. Actually, I'm Venezuelan. I'm from Latin America. I've been here for the past, I would say, 8 years.
Right.
2015, something like that. Yeah, it's been a
Awesome.
blast. But yeah, a little bit of the world, I've been here, there, and also developing projects. I would say like across the world.
Yeah. Yeah.
Saudi Arabia, like here in Europe, Singapore, United States, Canada. I don't know, like a lot of places, and I
Awesome.
feel very grateful about it. And a lot of like with huge companies, I would say. So
Yeah. Yeah. All EPC companies.
no, I mean like we're the PC companies. The most clients are like operators,
Oh no, sorry.
EM.
I meant your personal career.
No, I have experience at both sides. I used to work in the state oil company of Venezuela, also as a operator client, as a mechanical engineer, facility engineer.
Yeah. Yeah.
Always like in, I would say, technical areas, a little bit of static equipment, vessels, tanks. A lot of piping though. I really like a lot of piping, both sides. And then I would say the other half will be yes, purely in EPC. Yes, doing mostly engineering.
Right. 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 All right. So thanks for giving us some context and background,
Thank you.
Geronimo. Let's just switch screen to you sharing your screen.
All right.
Let's give us a second. It always takes a few seconds for it to uh, stream towards YouTube. Yes, there we go. Yeah, so maybe you
Mike,
can
could
kick
you
things off,
could you,
Geronimo.
could you corroborate that I'm sharing my screen now? Yeah.
Sorry?
Can you corroborate that I'm like
Yeah,
sharing the screen now? All
yeah,
right,
people can
everyone
see
might
your
see it.
screen.
All right,
Awesome.
excellent. So let me give a little overview. So among many things like we do on a daily basis, this course is focused on like having your 3D model, Smart Plan 3D, and your typical uh, piping stress software, and the way you could like do interface between them, and then
Yeah,
we'll call that optimizing, because we will take it to a different level, and that's beneficial, right?
right.
So I will begin with general stuff. This is part of the course, but also it's part of general knowledge. So we're going to be discussing about general stuff. Hopefully it's fun. We could have some fun like looking at it. So I'll jump right into it. So I will start with like common regular procedure of like within a engineering company, busy company, that it's big enough to have this, let's say, standardized. All right.
Right.
So this will be a typical piping stress analysis workflow within a company. All right.
Yeah,
So and allow me to begin with, before getting to this point when it says beginning or the start point, there's a lot of things that to needed to be done up to this point, such as like getting information from P&IDs, lists of equipment, line list, basically, plot plans, everything. But
yeah,
let's say once you get to that point, you when you're working in, let's say, medium, large, mega projects in size, all
yeah,
right, you tend to use this 3D model tools, all right, software. In this case, we're particularly speaking about SmartPlan 3D, all right,
yeah,
and but there are other softwares. Okay, so the main idea is like, okay, you have your 3D model, and then you have to since we're focused on stress analysis, you would say, okay, I need to do a stress analysis. So how do I, in a very like superficial kind of way, you would, okay, you start with your 3D model, all right, or with
yeah,
isometrics, all right, and either you have like two or several ways to do so, but two main ways. One is direct transfer from the 3D model, all right.
right.
That's what we want. That's why we're here. And then you will have your typical procedure of manual transfer from ISOs or the 3D model. When I say manually, you use basically will have your 3D model, and you might be like measuring and inputting information manually in Caesar 2, for example. All right.
Yeah, yeah,
So after that, you get a 3D, like you get your own stress model, which is in 3D, but it's your stress model in Caesar 2, right? And then, okay, after you have that and check a lot of information, input information, and selection of load cases, like and other variables, All right, you get to do what is important, which is the stress analysis. In fact, you get to analyze that, you get results, and you could say, okay, this is good, this is not good.
Yeah.
All right, and upon this, you would say, okay, are the results under allowables? Like, okay, is it under allowable values? Like, I don't know, stress levels, like nozzle loads, displacement, loads on like load ratings, all this stuff under strains. All right.
Yeah. Yeah.
And then there's two ways to it. That one, if it's no, okay, you start. So it's an important thing to mention that we try to always maximize the design that is coming from the design team, right? Like you always try to solve the problem with supports, or maybe playing with stiffnesses, whatever. But it is important to always try to maximize the use of the original design,
What do you
unless
mean
that.
by that? That the designers um, already put in the support basically
Yeah,
for stress
so you
engineers
try
to check.
to. Sorry, can you repeat? I'm sorry.
So basically, the designers or piping designers already put everything in place as like they estimate would be a good routing and a good support layout, and then
Yes,
the
yes. So
stressors
that's what I'm
verify.
saying. So yeah, so they would like do. It would vary upon experience, of course, right? But they would like do a job that, from their perspective, it's correct. And what we're doing basically is just assessing or validating that design from the stress point of view, right? Like from the
Yeah.
mechanical integrity point of view. So what I'm saying this is like, okay, we always try to maximize the use of that original design, unless the thing is like crazy, or your results are really bad, or
Yeah.
really bad, right? Or it's not working. So let's imagine you need to introduce some changes to the design, right?
Right.
And then you get a new design. This new design could be something small, or it's something that could be significant. It will vary upon the case, right? And then you propose a new design. So you have a new design and say, okay, this I have this in my scissor too that says it works, right?
Mm.
Then you gotta go to this, let's say I will call it debate, like negotiation with the designer, because you might have a point of view that might work for you, but not necessarily work for the plant. Like, I don't know, it could
Right.
be,
Right.
yeah, it could be, for example, like you're basically in a different elevation and you have a valve there, and you were assuming like, okay, from the stress point of view is good, but the designer might tell you, all right, but that valve needs to be accessible to for
Exactly. Yeah.
maintenance or for operation or whatever. So that's also a thing you gain upon experience, but it's always to have this, interaction with the designers. And let's say, okay, your proposal is good enough, and then you say, okay, the designer agreed to, and he will include your changes in the 3D model, right? Basically.
Mm.
And then when you have that, and we will go back that to the first point, like right in the right corner, to say, okay, are the results under the allowables? Then the answer is yes. What you basically do is like, then you basically start your support modeling. You either, like, if you're in the capability of doing it yourself, you could do it yourself, or in your company the designers are the one in charge to do so, they will do it.
Yeah.
But ultimately that will be one of the final steps in this whole process. And then when that, you have two more outcomes to that. That will be one, like producing piping stress reports. That's the deliverable on your scope.
Yeah.
And then, yes, and then in the other hand, you will have, yeah, the design team is informed about it, and then it's the design is approved. All right, there are other disciplines involved, and then basically the designer or whoever is in charge, they will produce the isometrics, and the end, like, would say product will be the ISOs for construction. Then
Yeah.
that will be within the engineering phase of it, right?
Yeah. So that is like uh, it sounds utopian to only have one set
Yeah.
of ISOs being made, right?
Yes, yes. Well, it will depend on how the company operates, right? Like, I would say, worked in companies where you don't actually issue an ISO until it's final, until the
Till the very end. Yeah, yeah.
very last. And then I would also work in other places where you just like a constant motion of it, and then you would like, and it's a machine that never stops. That you will be receiving changes, and it's really interesting with this new model business this day. I would say that is really challenging, because now I don't know, there might be some model businesses where you're like almost working in parallel with process team and other like
Yeah,
disciplines that are important, that in the past basically you would have a lot of information that will be settled, and actually decrease the amount of changes within it. But
yeah,
yeah,
exactly. So
yeah,
just a question for related to this slide is like the negotiation phase, as you mention it, and
yeah.
basically going back and forth between pipe design and pipe stress. Like what would that look like in practice? Is that like a daily thing? People sitting behind these desks, like next to each other.
Yeah,
What is
so
your experience in that?
it will vary upon whatever setting the company might have, right? Like you would be working remotely, for example, you will be working on the same building, you will be working like sitting next to each other, to 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 the very end of you even have tools to basically either you could go to a software and basically like publish some sort of string version of your design, and that could be built into the 3D model, and they could assess that
Mm,
upon your current situation, or upon your whatever specific situation you might have. My personal recommendation, though, since this is all focused on like improvement and based on like being more productive and anything, I would say like the best way to do so, if you have the opportunity now with technology these days, is just to like just call the guy or the girl and basically
Yeah. So
explain the
but
situation.
what I'm understanding is like it's not like a meeting a week type of
No,
setting,
I
batching
mean,
all the changes.
depend on your setting. Yes, it could be on a daily basis. Yeah, like if
Yeah, exactly. Yeah.
depend on your the amount of production you're handling. But typically, going back a little to it, typically I would recommend to be like, okay, you could even like send email like with this print screen. You can have your marked up isometrics, like your stress marked up isometrics with dimensions on it and what you have on your mind. And then it is always good to that like the idea, whatever is in the software and the idea do you have, like will be like fully implemented or implemented good enough for the thing to work.
Yeah, yeah.
That would say to yes.
All right. Yeah.
All right, let's continue then. Interesting thing here. So okay, so one of the main things of this let's say tool or this process is, okay, you have information in your 3D model that you would like to take advantage of it, right? Instead of you manually transfer that information to Caesar 2, right? This is the
Yeah.
software we're speaking of right now. So, what question question we could ask is, what do you think will be the required data to build your model in Caesar 2?
Right.
It's so yeah.
That would
So,
be
all right.
quite the list. Yeah.
Yeah, that will be quite a list. Let's try it out. Let's try it out. Like let's play a little bit with it, and we could go from the most, I don't know, the simplest one to the hardest one. So
All
yeah.
right. All right.
So I would start with the easiest one to leave you with the most difficult part. So no, no problem. We could play around with it, but okay. Evidently, let's say diameter, of course, materials, schedules, piping schedules,
Thickness,
all
the
thicknesses. Yeah,
schedules, right? Yeah. Yeah.
yes. Uh, what else? Like your
Coordinates, right? Like dimensions or
yeah, the design, yeah,
yeah.
like the layout, the piping routing, the I don't know, the operational conditions, like in terms of pressure, temperatures. What else? A lot of things. Do you have another one, like
Well, I would
in
say
the next
basically all information that is on typical isometrics should be in those PCF files, right? Even things like Um,
and more, like
and more,
less
right?
more. We will talk about it in a minute, but typically that information, it's coming from a specific plate. It's either placed on an isometric, but an important thing is in this procedure in particular, you don't need an isometric to build your stress
Yeah,
system within
yeah.
scissor 2, right? So okay,
All right,
all
so
right.
let me give it a go. Insulation, refraction. Like I'm just thinking about like the
No,
checks
don't worry about it.
you typically
Think out
do
loud.
in
Think out
before
loud.
your model finishes. Um, T types, right?
Yes,
So
yes.
something about sieves,
Sorry, say it.
and you know the well, design code, right? That's
That's the most important one. So I'll
yeah,
change to the slide, and like we could feel whatever is it's missing there, right?
right.
So of course I would say material, diameters, wall thickness. We just said like temperatures, pressure, fluid density, which is really important. It's not the same working with a gas than liquid. All right,
Yeah, yeah, yeah,
that will vary your sustains a lot.
yeah,
So your sustain loads, insulation, like density and thickness, corrosion allowance, equipment data. Like I would say, like if you have a nozzle connection, right?
yeah, yeah, yeah.
And what else do we have here? Like, of
So
course, the layout.
support layout. That's a comment we got from Sean Santos. Thanks, Sean, for sharing your thoughts.
Mhm.
Like support locations and restraints, right? Oh, it's at the bottom. I see.
It's in
Um,
the bottom. Yeah,
what about friction?
friction is important depending on the business. So I've worked in places where small diameters and because friction is a it's a it's an intricate thing, right? Like it has its nuance. Back in the
Yeah,
day, it was really hard to handle it. Now with computational powers this day, it's easier. But I've worked in other with people that or in businesses, but they don't care that much about friction. And but to be fair, the sizes are not that big. In the other hand, like we care about frictions a lot, like about friction a lot. Like I mean, you always try to avoid non-linearities
yeah.
within your calculation, but yeah. So I would
Is
say friction is important.
is
Yeah.
friction in the PCF files?
You could map it to it, like
Yeah,
so the PCF file would include a let's say you would have a support model, all right, and that
yeah.
support will have an ID, basically a code, right? Like if you work
All
with
right.
your own support standard, basically what you do is within Caesar 2, we're going to talk about it in a minute, but like when you get to that point, you're able to map that thing into Caesar 2 to tell the program, right, every time you see this code, just add this type of restriction, and then you're able to include the friction there, the friction
Yeah,
factor,
yeah,
which is important. What else do we have here? Like boundary conditions is always good to know where to stop your calculations or the scope of your calculation. What else? As you mentioned, it's left blank on purpose. The one of the most important things, the Bible, it's your code, right?
yeah,
The
yeah, yeah,
design code you're going to check your stress on.
yeah,
So I'm mentioning this because as you might be able to foresee, it's basically data that you need to that you're required to do your input that you might be able to get out of this PCF process. I mean, like out
right.
of this process from the PCF file, right?
Yeah.
So it's important. We will talk it out. We will talk about it in a minute. But I think you could get. It's not a perfect process, right? It's a very responsible thing to say, but it has improved a lot over the years. Up to I would say more than 90% of what the information you need, you might be able to get it out of the PCF files.
So one question related to that is so let's say a pipe stress engineer receives a PCF file as the basics for his work. What are typical, let's say, potential assumptions that a pipe stress engineer would make, and in relation to that, so what are actually questions that the pipe stress engineer should ask to the piping designer before just taking the PCF file and start working? Are there any like potential mistakes or assumptions luring that are interesting to mention?
That's a good question. One of the, I mean, if the piping stress system is really ready to be analyzed, I would say nothing. I would say okay, like, because you're receiving that to basically perform your stress analysis. All right. So the first question will be like, is this ready for me to analyze it? Is one fair question. But
Exactly.
after that, no, like you would need to check something after you complete the first step of the process. There's always information I think it's always important to check. Like
Yeah.
for example, like branch connections, SIFs, as you mentioned, it's quite important there. Like a lot of stuff like we could go over,
Yeah.
but yeah, I wouldn't say there's any other question than like, okay, given my system, I will like analyze it, and then like we will speak upon results.
Yeah. All right. All right. Yeah.
Yeah. So I will do this quick pause to tell you one important thing I would say, which is like let's talk about numbers, which is a really good thing. Like let's talk about raw and round numbers to highlight the benefits of this tool, right? Like for example, like implant design, right? There's a percentage of piping that it's going to be in that design. So what do you think will be like? Let's say let's flip things a little bit, and what do you think like in a plant design? How big do you think piping is within plant design?
All right. All right. You're kind of quizzing me, which is good. Which is good. I would say a fairly decent amount. I mean, you would have to
Right.
place look like equipment but at least I would say at like 50% of, I don't know, 40-50% of, well, maybe even
I
more,
would
like
I
man
would
hours.
agree with that. I would agree with that. Because the other like the other big one might be structures. Right? Like there's a lot
Mm,
of civil structure kind of thing. But yeah, I would say let's keep like 50%. Let's say okay, in plant design, a 50% is piping, right?
yeah.
So okay, next step. So out of that 50%, which is big enough, like it's really huge. How like what will be the percentage of that out of those the 100% of piping system? uh, what do you think will be the percentage that requires stress analysis?
um so that's a more tricky question. I mean, it obviously depends on
Yes.
the system, but and temperatures and stuff. So in like, I don't know, general plant, like
Yeah, it will.
to be honest, I find that very difficult.
No,
Okay, so
let me
let's say
let me
forty
help you.
percent, but
Let me
that's
help
kind of
you.
like a
Then.
guess.
Maybe I don't know. I would say it's more, but again, it will vary upon let's say your stress spec, right? Like on your criticality, right?
Exactly.
How that criticality is set, right? What do you call category one, category two, category three? What requires a formal calculation? What requires whatever? So it's important. I would say I don't know in a regular process plant, I would say 60%. I would say 60 to
60.
70%. So yeah, that's a lot. I mean, like you have
Yeah.
like you're building like these type of plants, you would have like very critical piping systems. So okay,
Yeah.
let's set up to 60 to have some fun. All right.
Yeah. All
And
right.
all right, so the most important question will be right now is um okay, you got to do like your job is to perform like do some stress analysis, right? So how much time do you think it will take you to build the model and then fixing the problem, right? So let me help you a little bit. So okay, as we've been like talking about, like you require a lot of information and you need to spend quite some time building your stress model, all right?
Yeah. yeah.
and then you're able to press the running man, and then you will get results. And then I would say the most important, but one of the key points of it or parts of it is like solving the problem. So what do you think will be the amount of time spent like building the model, and what do you think will be the amount of let's talk about percentages. What do you think will be the percentage, like
That's a
give
good
me
question. We had these competitions with between colleagues to who could have
yes,
built the model the fastest, right? So
yes,
there was definitely some difference. All right, so let's say I would say um 30% building and 70% stress analysis. And like
really.
I would say that like the majority of pipes would be okay from scratch, but then there's these nitty gritty points that require a lot of attention. I don't know, that's just me
Right,
thinking
right,
out
right,
loud.
right. Okay, okay. Let me help you with that a little bit. So I would say it will vary like upon three main things, right? One will be engineering, like the engineer experience, right? I would say, well, let's
Definitely, yeah.
split it in beginner, medium experience, and then experts, all right? Also, it will vary on the size of the piping system, right? Like you cannot take the same amount of time, like for example, doing a stress analysis for 100 ISOs than for 20 ISOs, right? Like
Yeah, yeah.
that also had like influence on it. And then the complexity of the stress analysis, right? It's not the
Mhm.
same, like for example, doing a stress analysis for a pipe rack than for a I don't know. So
Exactly, yeah,
so
yeah.
yeah. So I would say so. Let me embody these numbers. Trust me on this. But I would say it will vary. Like if let's settle on medium size piping stress system and a medium complexity of the stress
Yeah.
system. Then if you're focused mainly on the experience, I would say I'm not going to say a number though. I'm just going to say like if you're a beginner, you will spend a lot of time like building the model and then solving the problem.
Yeah,
But as
could
you
take ages, yeah.
progress with your experience, you will get to a point like okay, medium experience engineer, okay, it will take some time to build the model, but the solving the problem phase will be faster. And then if you go to an expert, I can guarantee you this like 100%, the expert will spend more time building the model than solving the
Mm,
problem because he's super
yeah.
used to do that. All right. So this is where this thing it's key. It's like it will help you to get your get your let's say your piping stress model faster, right?
Yeah, exactly. Yeah, yeah.
Quick- Quicker and less error prone though. We're gonna talk about it in a minute. So
Yeah.
now that we're at it, all right, which is important, what would you say it's a complex piping stress analysis? Or
Well,
let's start with EC. What do you say would be an EC? Like I don't know.
well, I mean, the variable would be, in my opinion, the temperature of the system and the amount of equipment connections. That's my first thought.
That's good thinking. I would
Yeah.
say I don't know, man. We're like just having fun. I would say EC we can settle on pipe racks, for example,
Oh, yeah.
regardless of the temperature. I would say like that's maybe calculation can be done by hand. Maybe I don't know. If you're up for
But
it.
I think pipe racks like these days, most piping designers know, and I've seen so many that the initial like input will be. I mean, there's not much, yeah, custom or difficult. Like I would say like a good piping designer could make like a good first draft even without stressing it.
Totally, totally. Depending again, that will vary upon company, but yeah. So I would totally guarantee that the higher the experience of the designer, the less stress analysis change that I mean, the less changes will be required from stress analysis because
Yeah,
they
yeah,
get used to design this these piping layouts like super very they're really good.
yeah,
But
yeah.
I would just say pipe racks because that's like to be honest calculations you can do by hand like using nomograms or some stuff like that. Basically you're like if you don't have any specific requirement to it, you would just set the locations of your loops and that's it, right? And then you will have branch connections which are important, but then you can solve those.
Hmm.
And what else? All right, so that's easy. What will be medium? I don't know. And then one example for medium, one example for crazy.
Medium is difficult. Like crazy is more easy. I
All right,
think like
what's
pump
crazy? All right.
connections, like these pump nozzles are always they have such low allowable values, right?
Yeah, yeah, yeah. I mean, that could happen. I would say the complex stress analysis would say, I don't know, like, or fun. I would catalog them as fun. I don't know, jacketed piping, or
Mm,
maybe reciprocal. It's like if you're connected to reciprocating
exactly.
equipment.
Yeah, low nozzle allowables. Yeah.
Yes. Also, like for example, if your typical vacuum fractionator transfer line with a lot of branch connections to it, a lot
Yeah.
of
Yeah.
risers.
Yeah.
What else? I don't know. There's a lot of expansion joints are always fun. Like for example, transfer lines from in flexi cookers, for example. That's really interesting.
Hmm, hmm.
Having refractory lining also. I don't know. There's so many examples to it,
Yeah.
but okay.
So
Okay,
so
let me. Yeah.
but uh like we have some comments. I think it's worth, Geronimo, to
Oh, okay.
move
Shoot. Yeah,
just to
yeah, yeah,
include those for a second. Is like first of all, in the set of information you have in front of you,
yeah. Yes.
line
Sorry about
numbers.
that.
I mean, typical line numbers is very important, obviously, in the 3D model, and Smart Plan 3D.
Yes.
Um, do Are those included in the PCF files and in typical your Caesar experience? Do you include those?
Yes. Yeah. So I would like the answer will be definitely yes. So you would have that information, but what you built in Scissor two, you could be. So there's an excellent question. So you will get in Scissor two as a line number, you will get the PCF file. So whatever you have in that PCF file. So you could set your PCF to. I'm going to speak in Smart Plan 3D language. Okay.
Mm,
So you could set it as what would be a pipeline within SmartPlan 3D, or you can set it upon levels of isometrics, right?
right.
So you are actually, that's one of the things I like to teach in these courses. Like you're in control of that. So the typical setup will be in pipeline in Scissor 2, all right?
Mm,
Sorry, I mean pipeline in SmartPlan 3D, and then you will have it here. Your line number will be the name of your PCF file. That's it. And the name of your PCF file will be basically the name of the isometric or of the pipeline
ah,
you selected. So
ah.
there's several packages to it, but yeah. So you're bringing that thing into Caesar 2, which helps you a lot. Another good thing though is like you also have the name of your supports,
Mm.
the tax for your supports. That's also another information that you're able to bring. All right.
How about units?
Units the same. So if you allow me to, there's this next slide, this one that I'm
Yeah.
showing right now. We could talk about material supports, SIFs, and units. So we'll cover that.
Ah, yeah.
And there's still a question, like a remaining question. We can like jump back to it.
Yeah.
So okay, so let me finish this super quick because I think it's very important. I will be quick though. One of the main benefits of this thing is, as we said, is time. Basically, it's like the time you save. Okay, and time
Exactly.
is
Yeah.
money, right? So let me give you a quick number. You can like whoever is watching could grab the calculator, or you can grab the calculator. I'm gonna
I left mine at home. Yeah. So you're
no, no
welcome to do
problem.
it.
I'm just gonna like spit some numbers, and you can like do the math. So whoever it's in the like interesting in seeing these numbers, like I can testify those. All right. So let's imagine super quick. You have 100 piping systems. All right. You have a P&ID. You have your plan. You have 100 piping system. And then, as we agree in the beginning of this argument, you let's call it like 60% requires stress analysis. Okay, so
Mm,
you have 100 piping system, then you end up with 60 piping stress system right now. All right,
right.
that requires stress analysis. If you get to an average of 40 hours, let's say a week, right? Like split in
Yeah.
five, right? So if you on an average spend 40 hours per analysis, you end up having like 60 times 40, you end up having 2400 engineering hours.
Yeah.
So out of those, yes, so that's basically like in round numbers, raw numbers. And then what will be the amount of percentage that you think it will be like that you could save? I would say 40%, because
Yeah.
if you establish in medium range that it will be 50-50, like 50% of the time building the model, 50% solving the problem on
Yeah. Yeah.
average, then it's not a perfect process. You will still invest 10%. All right. So I would say you save 40%. So that's 40% of 2,400 hours. And that's a lot. That's nearly, I don't know, 1,000 hours.
Yeah.
Right.
Exactly. Yeah.
So, yeah, so you're able to like save a lot. All right.
Mhm.
So, okay. Do
So,
you have many more questions from the
there's
audience?
one actually. There's one actually that we could mention here. Um, so, I mean, just to wrap up, like from Caesar to 3D model. So that's basically the other way around, right? So from S3D to Caesar, there's the PCF tool that you can use, or option. You have to know your way around, which is what the course is about. But can you also go back?
Yes, you can go back. So yes and no. So you are able to, again, it's in these slides, but you're able to bring your planned graphics into your stress model, and you can like come in full circle to it. If you just give me a couple of minutes, I'll get to it, and
Sure,
and we
sure. Yeah. All
like
right. All right. Let's put
and
that on hold.
still,
Yeah.
if we have more questions at the end, we can answer them all, no problem. Okay, I'll speed up a little. But okay, in typical piping, like, okay, this slide is really important, because this basically sums it all right. So what we want is, out of your piping 3D model, like you will have your 3D model. That 3D model in this case in particular will be in SmartPlan 3D. You can see it in the image on the left. And then in SmartPlan 3D, in drawings and reports, you can create a report basically that will produce or give you PCF, which is PCF, by the way, stands for piping component file. It's a regular
Mhm.
name, all right? And I always like to put it out as a, imagine I give you the task to like write down instructions for me on a piece of paper, not drawings though, but instructions like written for me to
Yeah.
like on my own to draw to basically draw an isometric drawing. All right, so
Yeah. Yeah.
it is basically, that's one of the uh, like the basics of it. All
Yeah.
right. So then out of Caesar, like out of the Smart Plan 3D, you would get your PCF file. All right. And this PCF file, I will show you what is inside this PCF file, what is the key information and how you can play with it. But to answer some of the questions, like within Smart Plan 3D, you're also in control to set up that package. It's called package, right? Like, so the default one for this is the ISO stress package, and
Yeah.
it's a PCF built specifically for Caesar 2, which helps a lot. It improves the process a lot. All right.
Yeah. Yeah.
Then you have your PCF, and this is, I will call, all right, like, upstream downstream of it. All right, like PCF is right in the middle. It's a file. You will get files as you might get, as I said, pipelines, or as you might get isometrics. All right,
Yeah.
and then you're able to build this file in Caesar 2. And it's
Yeah. Yeah.
basically what we want is like, okay, we want to take advantage of what is already in the 3D model, piping wise, and to put it fairly quick and accurately in
Yeah.
Caesar 2.
Yeah. Yeah.
That's what we want basically. So we have several tools to it, and that's basically sums it up. All right. Then we have within Caesar 2. So imagine you get to this point, like you already have your PCF. All right, PCF
Yeah.
files. All right, and then there's several things you could do inside Caesar 2 that will help you to improve the process. One of the things is the C2 mapping files. All right, basically you have the capability of mapping, which will be basically translate or tell the software, okay, whatever you see here, put this thing here. So for example, when so for let's go one by one. So for materials, okay, you're able to map your materials ID. It's basically translate, interpret. You're telling the software every time you read this short description, longer description, just assign a number from the material database within Caesar 2.
Yeah.
All right. And then there's the same thing for support. Like if like you can customize like whatever you might have within your company or on or your project specific data,
Yeah.
right?
Yeah.
Let's imagine you have your own like let's say your support specs, like with your own codes, your own type of supports. Then you're able to grab that code and tell the software, okay, every time you read this code, assign this type of restriction.
Right.
It's
Right.
a it's like a
Yeah.
guide or stop plus y whatever with
Yeah.
friction with gap though. You can also
Yeah.
add
Yeah.
gap.
Yeah.
All right. And then I almost never use the so materials are important, supports are important. SIFs, it's delicate. So you got to be careful with those. All right. You have the capability of like even include the stress intensification sorry the stress intensification factor like in plane out plane. You can tell the program like every time you see this code you put these values, but I
Yeah.
think it's kind of that's actually one of the things I recommend to review. All right, like once you're done with your import of your PCF files, then that's one of the things I always recommend that you need to check. Okay.
Yeah. Yeah. Yeah.
All right. And
So
then you
sorry to interrupt. Like, let's speed things up a little bit, Geronimo. I mean, we're
we're
45
we're,
minutes
we're,
in.
we're about to finish.
All right. Awesome. Awesome.
So okay, and with units, I've never like used them actually. So almost every single time, like it is there. So, but then you have the capability to do so. All right, and then super quick on this one, it was introduced a while ago, but these two tools like block operation, um, allows you to edit some things within Scissor tool and basically because once you do the import, all right, like then you will have a piping system. So you could do it different ways, but then with these two options, you have the capability of, reverse the order and play
Mm,
with the node numbering and then change sequence. So you would have within Scissor tool, you have in list, you're able to move one block to another, like change positions, all right?
right.
And then finally, all right, you also like coming full circle, you're able with this type of technology to bring your plant graphics into your stress model. And you
Yeah.
can use this in so many levels. Like you could like when you're starting the piping stress for the first time, you can bring the environment. This is Caesar 2. So you can see
Yeah.
right
That's
here
useful. Yeah.
that's super useful that you're able to see maybe support locations like availabilities on space whatever, and then you could use it the other way around. Like for example, if you send some changes and you want to validate if those changes were implemented
Yeah.
or
Yeah.
by some reason something changed, you could also bring your typical smart plan review files. You could input it into Caesar 2, and then you're
Yeah.
able to see stuff like this. So we could
Yeah.
play find the
Awesome.
differences. So you might be able to see their differences here. So then allows you to have a lot of quality control, quality assurance
Yeah.
kind of thing within the stress world, and it's super good. So let me put you an example super quick. So for example, imagine you have an underground system, for example, for fire water or whatever that will be in a big plant, 200 ISOs, and then something change. You're able to like bring your system like put the whatever is in the 3D model, and then you're able to graphically like see the changes and then like change things specifically instead of like going through a lot of information, which also saves a lot of time. And that's basically it. Like you have your typical advantages to it, the benefits. I would say the first most important is like okay, inputting data manually could be error prone and could be
Yeah.
inefficient sometimes, and sometimes could be risky also, right? Because it's human error related, and with this tool well, you're able to like reduce the amount of time spent, reduce the errors because it also eliminates unnecessary steps, and then of course you would increase your productivity and accuracy,
Yeah.
and
Yeah.
then it helps you save money. I mean, basically, like we all want that, like increase your profits, I would say. And then, yeah, the rest of it is basically, you have more control. The tools we were talking about, you're able to organize your system the way you want it. It allows you also to, so if you're working in coordinates, you're able to selectively update sections, portions. Like you could
Mm.
update a single PCF here, and you could update it, then fix it up a little, and then you don't have to be. But that's upon judgment. Like I always, so don't see this as the only tool you might have. You will have several tools. This is just another one. You are the one in charge to taking the right decision, right?
Yeah. 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 Yeah.
And again, as I would like showed just recently, it facilitates the comparison between whatever it's in the design and the 3D model with your stress model
Yeah.
to use
Yeah.
at your
Exactly.
advantage. All
Yeah.
right, that's it,
But
man.
I mean, the
That's
main
all.
takeaway is clear. I mean, if you set this up correctly, it could save a ton of hours. I mean, the example you mentioned, it came up to 1,000 man hours. Um, just maybe to wrap things up. Let me just briefly share my screen. I'll take a second. Yeah. So let's see if it's on. So, I mean, the course, I'm just sharing the view of the course here on engineeringtraining.com. In this course, Geronimo, you will go into depth about these things and the software settings and all things related. Again, if this topic is relevant to people, make sure to check it out and see if that could be of value to you. Let's wrap things up with one final question, Geronimo. Is like, when you set things up correctly, is there a lot of work to be done after importing the PCF into Caesar? Let's say process settings, elbows not being imported correct. Like,
Yeah.
are
So
you do you
yeah,
still need to do that work?
there's always, and I say this really responsibly. There's always an amount of work that needs to be done after you import your PCFs. But I would say that it like this been here for a long time. What I would say is like it got to a point like I can guarantee that we've done it successfully, and I can testify about these benefits. So there's tricks to it that I like to show. Like for example, you could like rearrange and so there are different ways to do so. So you have the capability, for example, if you have a header with a lot of branches, you could like build the header first and then the branches, and
Yeah.
then like organize everything. You might have some minor issues to it, and I will teach you how to deal with those. And my personal favorite, I think it's easier, is just I just bring the whole thing and then just like organize the thing as I want. And you could do it graphically. Sometimes like spoken to people that would say like, no, this is kind of like I don't know, I don't get like the graphs to it, and I will kind of give them some minor tricks, and the way like it improves a lot. So I
Hmm.
could say, so for example,
Awesome.
one of
Yeah.
the things you gotta be careful of is like when doing this type of like change sequences, you cannot move one to the other. Like if you have elbows in Caesar 2, the way it's programmed, you need to have on the list these two elements together.
Mm.
That's one example. But what I would say, like what will be really advisable, like is if you do it graphically, it will be like it will vary upon like every situation. But if you do it graphically, it's like way more faster. So,
Awesome.
to finalize this, I have a friend of mine that we, as you guys do, like it's a regular thing. We once did this competition of like it was 100 isometrics, like who would
Oh,
it
that's a
end it
lot. Yeah.
faster, like doing this and doing that, and I would say like guaranteed it was half time, like
Yeah. 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 Oh,
less than.
yeah. Yeah.
So one
So
final
that's
question on my
significant. Yeah.
side. Yes, one final thing though is like if you still have more questions, and because we're running out of time, feel free to contact me and ask away. I will be more than help the than happy to help you. So
All right, all right, awesome. So thanks, Geronimo, for your time and taking the time to go have a little bit of a discussion about these files and how to approach them. Obviously, in the course, there's a lot of in-depth discussion and software examples, etc. Um, uh, as Geronimo said, feel free to connect with me and Geronimo on LinkedIn and shoot us a message or a question if you have any inquiries. Having said that, Geronimo, I wish you a great day and for all our viewers as well.
same to you. Yes, to all of them.
All right.
Thank you so much for having me. That was fun.
It was fun, definitely. All right. It was a blast. Thanks all for joining and have a great day.
Bye.